Welcome back, students. Let us take up the next problem. The problem number is 4.5 in the drawing number 16. Like last problem, even this problem we are going to solve using our radial line development method. Okay, you can come out to the sheet. Let me read out the problem for you. The problem number is 4.5 here. The reference number from the VTU primary is 30, the drawing number is 16. This is a hexagonal pyramid, base side is 30 mm and it is given that it is the base side is parallel to VP. So you know how to draw a hexagon with one edge parallel to VP. Draw the development of lateral surface of the retained portion of the pyramid cut by two perpendicular planes shown by dark lines in the figure. Now this is the front view of a hexagonal pyramid. These are the two cutting planes. This is one and this is the other. That is how you are cutting the pyramid. You are first starting from here. This height is given 30. The total height of the pyramid is given as 60. So exactly at half height of the pyramid, you have started cutting with a horizontal cutting plane, then you have cut here. Okay, you have proceeded down. So this is the portion you are removing. This portion will be removed and you need to draw the development for the retained portion, the remaining portion of the pyramid. This is the problem. So it's a combination of two cutting planes, mutually perpendicular cutting planes. So once again, the cutting plane is changing its direction at this particular point. So like in the last video I have shown you, whenever the cutting plane changes its direction, that particular section point will be named as two section points. That particular point will be named by two section points. Let us come to that first. Before that, we need to draw the orthographic projections. Okay. So once again I will draw the orthographic projection on the right side, and left side I will use for drawing the radial line development. So I will start with a short XY line. You will draw a hexagon in the top view with one of the base edges parallel to VP. That is the requirement. So let us draw a hexagon with one edge parallel to XY. This edge has to be 30 mm in length. With this as one of the edges, I will complete the hexagon. Okay, so this is the hexagon with one edge parallel to XY. In fact, two edges are parallel to VP. Now let me draw the center. Let me find out the center for the pyramid. This is O1. Okay, now let us start naming the points, naming the corners. Let us say this is A, B, C, D, E and F. Okay, because this is a pyramid, you will also draw these dark. They represent slant edges. Now let us start drawing the front view. You are given the height. The height is given here in the figure. It is 60. So from here you draw a chain line equal to 60 mm length. Call it as O dash. This is O1 dash. Let us draw it using light lines first. Whatever is retained portion we will show by dark lines later. Now take half the height. The total height is given as 60 and half the height is 30. So how is the cutting plane given? You are cutting here like this and then proceeding downwards. So what is the retained portion? This is the retained portion. So this has to be shown with dark lines. Okay. So you need to draw the development for this portion only. So this is the portion that has to be removed. Now let us start naming the section points. Okay. Let me name the points on the base. This is A dash, B dash, F dash, C dash, E dash and D dash. Let me start from this end. Say this is 1 dash. Let me name the section points. 1 is on OD. Next 2 dash here. 2 is on the visible edge, OE. 2 is on OE. Next comes this point 3 dash. How to name that? This is in fact an axis. You can't name the section point on the axis, but how do you name it? If you look at the entire pyramid, there are two triangular faces in this location. One triangular face is OBC, which is in front. It's here in the top view, OBC. The other triangular face is behind, which is OEF. E and F you find in brackets, so that is behind. So I can consider the point 3 on the center line of the triangular face OBC. Okay, so point 3 I will write as the point on triangular face OBC. In fact, it is on the center line of that triangular face. Then come down 4 dash. Now this here, the point is exactly on the base. So the caution is that when the cutting plane cuts the base, it will be denoted by 2 section points. When it is cutting the base, it will cut at least 2 base edges. So what are those 2 base edges? You can come to the top view and verify. So it's cutting this base edge and also this base edge. So 4 we will take it on BC. 4 is on edge, base edge BC, and 5 is here. 5 is on the base edge EF. 5 is invisible. So 5 I will put in brackets. Okay. It's cutting 2 base edges, BC, which is visible, EF is invisible. So 5 also is invisible. I have shown in the front view. So now you are going back and you are retracing the path. As I mentioned already, this is a point where the sectional plane is changing its direction. So one more point will come there, 6 dash. You can consider 6 to be on the triangular face which is behind. What is the triangular face? It is OEF. Okay. It is in fact on the center line of the triangular face, OEF. And then the last point, 7 dash, it is on the slant edge OE, which is invisible. Okay, so that completes the orthographic projection. I'll come back and draw the development.